All right, CJ, let's try to knock off. I'm sorry that it is now afternoon on Friday. I'm going to try to do 25, 26, and 27 real quickly. 25, you should recognize what's going on there. If it was the parent function, f of x equals absolute value of x, the graph of that just looks like this. If we were evaluating that in the limit as x went to 0, the limit would exist and the limit would be equal to 0. Because whether we approach it from below or from above, y is getting infinitesimally close to 0 as x gets infinitesimally close to 0. So that's no problem, that function. And the this problem is analogous it just has a horizontal shift of 4. So you should recognize that that's the graph of the absolute value of x plus 4. And here, when we get infinitesimally close to negative 4, either from below or from above, it looks like the function is going to equal 0. And in fact, that is our limit. So that's one that can be done rather easily, I would say. Let's go to 26. And 26 is a slightly more complicated problem. I believe I don't actually have it right in front of me. Was it x minus 2 on top, the absolute value? Let me look real quickly. Crap. Yeah, so absolute value of x minus 2 over x minus 2, we're evaluating that in the limit as x goes to 2. And there, we can think of this in two, we can break it down into two pieces. If x is greater than 2, then the absolute value on top really doesn't make any difference. Oops. This doesn't make any difference. It would be if x is greater than 2, then this problem would reduce to just regular x over x minus 2 over x minus 2, which is just equal to 1. Let's think about when x is less than 2. Then the absolute value does make a difference. The absolute value basically multiplies what's inside the absolute value by negative 1. So in the case where x is less than 2, what we'd really have is negative x plus 2 on top over x minus 2 on the bottom. And the top is the opposite of the bottom. So in the case where x is less than 2, what we have is negative 1. If we think about what that function really looks like, it is doing this. It's equal to negative 1 all the way up to the point where x is equal to 2, and then it bops up to positive 1 on the other side of that. So we're getting two different apparent values as we approach x equals 2 from below. It looks like it's going to equal negative 1. When we approach x equals 2 from above, it looks like it's going to equal positive 1. Those two numbers aren't the same. So we therefore conclude that the limit does not exist. So that is 26. And then I'm going to do, I think we have two more, 27 and 28, which are variations of the same thing. They're one-sided limits. And so let's look at those real quickly. 27 says we're approaching this from below, so that's saying x is less than 0. And what we have is 1 over x minus the absolute value of x. But if 1 over the absolute value of x, but if x is less than 0, then this guy, the absolute value there is really multiplying what's inside the absolute value by -1. So it really reduces to, we can get rid of the absolute value. This is just in the case where x is less than 0. And we get that it's equal to 1 over x minus 1 over negative x, which equals 1 over x plus 1 over x, which equals 2 over x. Now, if we think about what is going on there, in the limit, as x goes to 0, this guy is going to infinity. It's a vertical asymptote, and therefore we say that the limit does not exist. I'll do 28, see if I can do it right on the same page. This is in the case where x is greater than 0. Now the absolute value makes no difference because x is greater than 0. X is greater than 0. So that means this guy, the absolute value didn't make any difference, so we can just forget about it. So that now we're looking at the limit as x goes to 0. Again, this is in the case where x is greater than 0, and we would get 1 over x minus 1 over x, getting rid of the absolute value, but that's just equal to 0. What does that tell us? That tells us that it appears when we approach this function from above 0, that it appears as if the function is going to equal 0. So the limit does exist, and it's equal to 0. All right, CJ, that is that. I'm going to send that to you. Hopefully you get it in time, and I'll talk to you later. Bye.